So now we will see order of an element. So what is the definition? On your screen you have the definition. Size of subgroup generated by an element. Okay, you have some element. What is order of that element? That is basically size of subgroup generated by that element. Very simple. So order of group is different. Remember, order of group, that is the number of elements. Order of group is the number of elements. And order of an element is what? What is order of an element? Order of an element, another word is period length or period. That is order of subgroup generated by an element. That is order of subgroup generated by that element. Okay. So for example, let's assume that you take this question. This question in the last class we have done 1 minus 1 iota minus iota and multiplication. So tell me what is the order of 1. First you tell me what is order of G. First you tell me this question, order of G, what is that? Order of G is 4. Order of group is 4. That is the cardinality of the group. Okay. Now tell me order of 1. Order of 1, that means the cardinality. It means the cardinality of subgroup generated by 1. Okay. Cardinality of the subgroup generated by 1. So what is the subgroup generated by 1? This is the subgroup generated by 1. So the cardinality will be 1. Because this is the identity element, you know. This is your identity element. Okay. What is order of minus 1? Order of minus 1. That means cardinality of subgroup generated by minus 1. Cardinality of what is subgroup generated by minus 1? That is this. So the cardinality is 2. Correct? So order of minus 1, that is 2. What is order of iota? If I ask you, order of iota, it means the cardinality of subgroup generated by iota. And you can notice that iota is a generator. You already know that. Okay, you already know that iota can generate the complete group and minus iota can generate the complete group. So I can say the order of iota will be 4 and order of minus iota will be 4. Okay, yes or no? So remember, this is the symbol, order of an element. If you have some group, then what is the definition? So let's assume you have a group G comma star. Let's assume A belonging to G. Then what is order of A? That is the size. That is the size of subgroup generated by A. Remember, this is the size of subgroup generated by A. Is this clear? Means how many elements this A can generate. So this is order of A. That means size generated. Okay. And this order of A, this we write like this also. So if I give you, for example, if I ask you, this symbol means order of A. Order of A. This symbol means order of A. So remember, this means order of element A. Here A is the element. And what this means? This means the size of subgroup generated by A. How many elements this A can generate? This is the order of A. Some people also write order of A. So all these things are same. Let's see. Let's see another question. For example, consider this U10. So do you remember what is U10? U10 is 1, 3, 4, 5. I think 5 is not. So then there will be 6, no, 7, 8, no, 9. Okay, so this will be the 1, 3, 7, 9. This will be the U9, U10. This will be the U10. Multiplication modulo 10. This is the operation. Now tell me what is the, first you tell me what is the order of U10. Means what is the order of this group. So that will be 4. Order of group is very simple. That is number of elements in this. Now tell me what is order of 1. Remember, 1 is the identity element. 1 is the identity element. So order of identity element, that will be size of subgroup generated by identity element. And what is the subgroup generated by identity element? That is only identity element. So order of 1 will be 1. Right? Because this is the identity element. How many elements identity element can generate? how many elements identity element can generate? Only one element. Identity element can only generate itself. Identity element can only generate itself. What is the order of 3? Order of 3 means cardinality of subgroup generated by 3. Cardinality of subgroup generated by 3 means 3 power 0. 3 power 0 is 1. 3 power 1, that is 3. 3 power 2, what is 3 power 2? Tell me. What is 3 power 2? This will be 9. 3 power 2, that will be 9. What is 3 power 3? 3 power 3, that will be 7. 3 power 3, that will be 7. So all the elements are generated. All the elements are generated. So I can finally say that order of 3 is 4. Now tell me, what can I say about this 3? So what can I say about this 3? This 3 is what? This 3 is the generator. This 3 is the generator. So I can say that 3 is a generator. Because 3 can generate everything. This 3 has generated everything. So 3 is a generator. And what is the inverse of 3? So remember, in this group, if you notice, 1, 3, 7, 9 in this group, and multiplication modulo 10. This is your group. Now in this group, you can clearly see, first of all, what is 3 power 3? What is that? That means 3 multiplied by 3 multiplied by 3 mod 10. Mod 10. And that means 7. What is 3 inverse? So which element should I put here such that I get 1? Such that I get 1. So which element should I put here? So what is that element which will give me 1? So 7. So I can say 3 inverse is 7. So 7 inverse is 3. So if 3 is the, okay, so what will be the subgroup generated by 7? That will be same as subgroup generated by 3. That will be same as subgroup generated by 3. And that will be G itself. That will be G itself. So what is order of 7? Order of 7 is also 4. Okay. So I can say 7 is also generator. So 7 is a generator. Because it can generate the whole group. 7 can generate the whole group. The subgroup generated by 7 is the whole group. And what is the order of 9? What is the order of 9? That is cardinality of subgroup generated by 9. 9 power 0 is 1. 9 power 1 is 1. 9 power 2, what is that? That is 1. 9 inverse. 9 inverse is also 9. So you can notice 9 inverse is also 9. So this, only these two elements will be generated. So I can say order of 9 will be equal to 2. So 9 can generate only 2 elements. Because you can notice 9 inverse is 9. And whenever 9 inverse is 9, whenever A inverse is A, then how many elements you can generate? A inverse is A. It automatically means that this will be E comma A. This we have seen. Whenever this situation happens, A inverse is A. Whenever this situation happens, then the subgroup generated by A will be A comma E. Okay. But remember, if A is not equal to E, if A is equal to E, remember A is not equal to E, but if A is equal to E, then what will happen? If you have this situation, E inverse equal to E, you already know E inverse is always equal to E. So this will be E only for identity element. So take care. Don't say exactly 2. So if I remember this point, this is if I ask you this question, like you have a group, and let's assume I ask you this question that A belongs to G such that A inverse is equal to A, then what can you say about this cardinality? Don't say 2. Don't say 2. This will be at most 2. Okay, so this will be the subgroup generated by A. This cardinality will be at most 2. Because you can notice if A is equal to E, then cardinality of then subgroup generated by A, that will be cardinality will be only 1. And if A is not equal to E, if A is not equal to E, then you can say it will be 2. No, it cannot be 0 because every group should be non-empty. At least you must have identity element, right? So no group, no subgroup, no group is empty. Empty You never take empty, because at least this identity element must be there. Okay, so don't ever take empty, never take empty. Okay, next. So this is the idea. So here, what is the subgroup generated? What is the order of 9? That will be 2. So if, what can I say about 9? Is this generator? Is this generator 9? This is not a generator, because it cannot generate all elements. So this is not generator. It cannot generate the complete group. Now, one very interesting thing you should observe, this observation. Basically, we want to make a observation. We want to make. Okay. So let me take one example to make this observation. Let me take Z10. And what is the operation should I take? Which operation should I take? If I directly give you Z10, then what is the operation that comes with it? Yes, remember, if I only give you Z10, then automatically it means that the operation will be addition modulo 10. Remember this point, because this group is popular for addition modulo 10. That is the reason. Don't worry, in the exam, they will give you the complete thing. This will be given to you. Everything will be given. But I am saying that this group is popular for addition modulo 10. So that is the reason the operation is addition modulo 10. Now you already know what is your Z10. That is 0, 1, 2, and so on 9. This is your Z10. Now some interesting things you notice. Okay, and then we will make a conclusion. Okay, tell me what is the identity element. Just check what is the identity element. Identity element is 0. This is the addition modulo 10. So identity element is 0. Now notice the first thing. Subgroup generated by 0. Subgroup generated by 0. Apply the definition. 0 power 0. What is that? Subgroup generated by 0. Because remember, subgroup generated by 0 means 0 power all integer powers. 0 power all integer powers. What is 0 power 0? That will be 0. See, in number theory, 0 power 0 is undefined. But this is not number theory. This is group theory. Remember this point. Okay, note. So just note this point, that in number theory, this happens. In number theory, what happens? That 0 power 0 is undefined, indeterminate or something, undefined, whatever, indeterminate in number theory. But in group theory, what happens? In group theory, what happens? 0 power 0, that is always the identity element. That is always the identity element. Okay, so very simple. In group theory, 0 power 0 is always the identity element in group. I can say in group, in any group, whatever group you have, 0 power 0 will always be the identity element. Notice this point. Just note this point. Let us assume this. You have this A, and what this means? This means you have A power 0. This is your identity element. That is fine. Okay, this is fine. You have A power 1. Let's assume. Now let's assume that A power 2 is also something. Let's assume A power 2 is B. Let's assume. Okay, just wait. Now if you get A power 3 as identity element, now tell me what will be A power 4. Just tell me what will be A power 4. Once you get this identity element, now what will be A power 4? A power 4 will be A power 3 into A. So it will be A. Now tell me what will be A power 5. What will be A power 5? A power 5 means A power 5 means A power 3, A power 2. A power 3 is E. A power 3 is E. Okay, so that will be A square. A square is B. So A power 5 is B. What is A power 6? A power 6. What is that? A power 6. That means what? A power 6 means A power 3, A power 3. And that means E dot E, that will be E. So this will be E. What will be A power 7? A power 7 will be A. Yes or no? Can you notice that? Can you notice that once you get this positive power, remember, this is the smallest positive power. Can you notice? This is the smallest positive power. Can you notice? This is the smallest positive. I am talking about positive. I am not talking about this. This is not positive. I am talking about smallest positive power such that you get E. such that you get identity element. Smallest positive power such that you get identity element. Then further you will not get anything new. Yes or no? Agree? Once you get this smallest positive power such that you get identity element, now you will never get now you will never get anything new. You will not get anything new. Agree? Very simple observation. Once you get this smallest positive power such that you get identity element, once you get this identity element which is smallest positive power, remember this is not positive. Remember this is not positive. 0 is not positive. 0 is neither positive nor negative. Okay, so once you get this, then further you cannot get anything. Agree? Further you cannot get anything. One more very interesting thing. One more interesting. Just okay, just another thing very interesting. You already know. Tell me if B into A is equal to E, then what can you say about B? In a group, everything is happening in a group. In group, if BA equal to E, then what can you say about B? Yes, B is A inverse. Agree? B is A inverse. So tell me, in group, if you get A power 5 equal to E, let's assume, if you get A power 5 equal to E, then what can you say about A inverse? Tell me, anyone want to tell me what can you say about A inverse? Yes, that will be A power 4. Agree or not? See, very simple. Because you already know that if BA equal to E, this we have already seen. If BA equal to E, then B will be A inverse. Remember this? This we have already seen. The proof we have already seen in group. In group, if BA equal to E, then what is happening? You are getting E. You are getting E. So it means this B is working as what? This B is working as A inverse. Agree? This we have already seen. This B is working as A inverse. So this B is working as A inverse. Also, you can do like this. You can also do like this. BA equal to E. Then what you can do? You can multiply. You can multiply with B inverse on both sides. So just multiply with B inverse on both sides. This will be B inverse. And this will be A. This will be E. So finally it will be A equal to B inverse. Or B equal to A inverse. Or I can say B equal to A inverse. This you already know. I am just telling you again. Now you can notice that if A power 5 equal to E, then what can you say about A inverse? That will be A power 4. Agree? Simple thing. Because if A power 4 into A equal to E, then I can say A inverse. This A power 4 is working as A inverse. This is working as A inverse. This A power 4 is working as A inverse. So this observation actually I am telling you to make. So this is the observation you can make, that let's assume that you have some group. So this is your note number. This is another note. So let's assume you have a group G comma star, and let's assume A belonging to G, such that A is not equal to E. Okay. Now in this situation, if you find this, and let's assume this situation happens. Let us assume that this situation happens, that of course first you will do A power 0, that will be E, but this is not positive. But this 0 is not positive. Now let's assume that A power, that is A, that is fine. And A power 2, let's assume that is B. A power 3, let us assume this is E. Now tell me, one thing you tell me, should I go further? Okay, once you get this, should I go further? No. But should I go in the reverse direction? Should I go, I don't have to go further. So because I got this, now I don't have to go further. I don't have to check A power 4, A power 5 and so on. No check, no need, no, nothing new. I can say this is nothing new. Now tell me, but should I check A inverse? Should I go into this direction? Should I go into this direction? Why no? Tell me why no? Okay, there is again no, nothing new. This will again be nothing new. Why? Tell me what is A inverse? Because this itself, you can notice this itself is your A inverse. You can notice this itself is your A inverse. Yes or no? Because A cube is E. Because A cube is E, it means A inverse is A square. It means you got A inverse as A square. So this A square itself is your A inverse. So what is A power minus 2? So A inverse is already A square. And what is A power minus 2? Tell me what is A power minus 2? That is A inverse power 2. Remember, A inverse is A square. So that will be A power 4. A power 4. And you know A power 4 is simply A. Because A power 4 is same as A. Are these small observations clear? Did you understand them? Anyone has any doubt? See, I'm very slow, step by step, I'm telling you everything. Are they clear? Step by step, see, I'm telling you small results. These small observations I'm telling you, and then I'm going to the actual thing. With example, let's try to understand. Okay, so don't worry. If you have any doubt, just try to understand with example. So I can say that this is fine. This you already know. Okay, so there is nothing new here. Actually, here there is nothing interesting because the subgroup generated by E, this will be simply E. Okay, so there is nothing interesting here. Now let's see where something interesting will happen. Let's see the second. What is the order of 1? Let's see where it will happen. See, now if you find order of 1, till where you have to go? Think about it. Till where you will go? You will go till only positive, smallest positive integer which will give you identity element. Yes or no? Where will you go? You will go till smallest positive integer which will give you identity element. So for example, 1 power 0, this is not positive integer. 0 is not positive integer, this will be 0. What is 1 power 1? That will 1. So it is not giving you identity element. As long as you are not getting identity element, you have to keep going on. What is 1 power 2? That is 2. What is 1 power 3? That is 3. What is 1 power 4? That is 4. What is 1 power 5? That is 5. 1 power 6? 6. 1 power 7? 7. Structure is Z10. 1 power 8? 8. 1 power 9? 9. What is 1 power 10? Tell me. What is 1 power 10? That is your identity element again. Now should I go further? Should I go further? Should I go further? There is no need, nothing new. You will never get nothing new. See, 1 power 11, 1 power 12, nothing new. This will give you nothing new. You can check. What is 1 power 11? 1 power 11, that is 1. 1 power 12, that is 2. Nothing new you will get. You will not get anything new, nothing new. And what is 1 inverse? You can actually check. You don't have to go in the reverse direction. What is 1 inverse? 1 inverse is 9. Can you notice 1 inverse is 9? Because see, 1 power 10 is identity element. This is identity element. So I can say 1 inverse is 1 power 9. So I can say 9 is the 1 inverse. Yes or no? Isn't it interesting? Like very small thing. You don't have to check 1 inverse because this is your 1 inverse. Remember, this is your 1 inverse. Okay, let's see the next one. What is the subgroup generated by 2? Let's check it out. So first you tell me, can I say subgroup generated by 1 is same as your actual group? Because every element is generated. Every element is generated. So I can say this is generator. So what can I say about 1? So this 1 is the generator. So this 1 is actually the generator. Okay, next, let's say subgroup generated by 2. Now notice what will happen. Actually, remember the definition says 2 power n where n is integer. This is what definition says. But I'm saying the definition says that you have to check 2 power 0, you have to check 2 power 1, you have to check 2 power 2, you have to check 2 power 3 and so on. You have to check 2 power minus 1, 2 power minus 2, 2 power minus 3, and so on. This is what you have to do. But what I am saying that if you get identity element, then stop. If you get identity element, go in the positive direction. Go in the positive direction. Once you get identity element, stop. And if you get identity element, then you do not have to go in the negative direction. Okay, so for example, with this example, this will be clear. So what is 2 power 0? 2 power 0, that is 0. Should I stop here? I got identity element. Should I stop here? Should I stop here? No, this is not positive. This is not positive. I should not stop here because this is not positive. Now let's see where I will stop. 2 power 1, that is 2. 2 power 2, that is 4. 2 power 3, that is 6. 2 power 4, that is 8. What is 2 power 5? Anyone? Anyone want to tell me what is 2 power 5? That is 0. Again, identity element you got. Okay. So what you got? You got identity element. Now remember, now very interesting thing you note. Very interesting thing. Just note it. Okay. Is there any benefit in 2 power 6? Will I get anything new? What is 2 power 6? Tell me. Anyone want to tell me what is 2 power 6? That will be 2. What will be 2 power 7? That will be 4. 2 power 8, that will be 6. Nothing new. I don't have to go because as soon as I get here, nothing new I will get. Now I will get nothing new. Nothing new. Okay. So this nothing new I will get. And should I go in the reverse direction? In the negative direction? Should I go in the negative direction? Will I get anything new in the negative direction? No, because where is 2 inverse? I already got 2 inverse. Where is 2 inverse? Where is 2 inverse? Remember, this is your 2 inverse. Because 2 power 5, see, 2 power 5 is identity element. It means it is like this. So what is 2 inverse? So 2 inverse is equal to 2 power 4. 2 inverse is your identity element. So this is your, it is your 2 inverse also. This is same as 2 inverse. So you can notice that you don't have to go in the negative direction because already you got 2 inverse. And what is 2 power minus 2? What is 2 power minus 2? That is 2 inverse power 2. And 2 inverse is 2 inverse you already know. 2 inverse you already know. That is 2 power 4. 2 inverse you already know. So that will be 2 power 8. And 2 power 8, what is that? I can say that is 2 power 5 into 2 power 3. 2 power 5 is identity element. This 2 power 5 is identity element. So this will be 8. Sorry, 2 power 3 is actually 6 because 2 power 3 is 6. Okay, actually, see what mistake I did. Did you notice 2 power 6, 2 power 3? We have a habit. No. 2 power 3 is equal to, what will be 2 power 3? The operation is modulo 10. So that will be 2 plus 2 mod 10. So that will be 6. Okay, don't make this mistake. Okay, so 2 power 3 is not 8, 2 power 3 is 6. This is very common mistake, let me tell you. Okay, anyway, so that is the point. Can I say 2 is the generator? Can I say 2 is the generator? What is order of 2? So you can notice that what 2 can generate. If you see what 2 can generate 0 identity element, it can generate. 2 can generate, see, it's like this, 2 power 1. So it can generate 2, it can generate 4, it can generate 6, it can generate 8, and it can generate identity element. So the order of 2, that is 5. Order of 2 is 5. And 2 is not a generator. I can say because 2 cannot generate all the elements. So 2 is not a generator. So that is the point. Okay. Let's move on and just tell me this point. Let's think about 3. Let's think about subgroup generated by 3. What that will be? You know 3 power 0 is identity element. That is fine. 3 power 1 will be 3. 3 power 2 will be 6. Okay, so here, for example, 2 power 0. Yeah. Okay, so 2 power 3, 3 power 2, that will be 6. And 3 power 3, that will be 9. 3 power 4, what that will be? 3 power 4, what is that? That is 2. 3 power 2, so 3 power, so you got 2. Now 3 power 5, what is that? 3 power 5. So you already have 3 power 2, 3 power 4 you already have. So 3 power 5 will be basically 5. Because remember, 3 power 5 is what? That is 3 power 4 into 3. 3 power 4 is 2. So that is basically 2 plus 3. That is 2 plus 3 mod 10. Okay, so that will be 5. So don't say that 2 into 3, that is 5, that is 6. No, this is 5. So take care. This is very common mistake. So 3 power 5 will be 5. What is 3 power 6? That will be 8. What is 3 power 7? What is 3 power 7? That will be 1. 3 power 8, what that will be? That will be 4. 3 power 9, what that will be? That will be 7. And what is 3 power 10? Finally, I will get 0. Finally, I will get 0. Can you notice? Can you notice? Now, one thing you notice here. One thing you notice here. As soon as I get smallest positive integer, this 10 is what? What is this 10? This 10 is the smallest positive integer. Yes or no? This 10 is the smallest positive integer such that you are getting identity element. Yes or no? This 10 is the smallest positive integer such that you are getting identity element. So order of 3. Okay, because this is duplicate, this and this is duplicate, so let me remove from here. Now can you notice order of 3 is what? That is same as this number. Yes or no? So order of 3, what is that? Order of 3, tell me. So this is same as your group. This, so I can say 3 is the generator. So 3 is the generator. And you can notice that. What is the order of 3? Tell me. That is the size of how many elements you can generate. So all the elements you can generate, right? So that is 10. Another way is this order of 3. That is smallest positive integer. This is the smallest positive integer such that 3 power n, smallest positive integer n, such that 3 power n is identity element. Is this clear? Is this definition clear? This another definition. Another definition. Order of 3 is equal to size of subgroup generated by 3. That is 10, because it can generate all the elements. But you notice this definition. The order of 3, where will you stop? Just tell me this point. Where will you stop? Okay, I removed 3 power 0 equal to 0 because this is already here. And this is a set. So duplication is not allowed. I removed this because already we have it here. This 0 we already have here. So duplication is not allowed. Okay, so you can notice one thing, that where will you stop? If you want to find order, let's assume if you want to find order of any element, then where will you stop? You will start, let's assume you start at a power 1, a power 2. Where will you stop? As soon as you will get this, here you will stop. Yes or no? Now there is nothing new. Nothing new you will get. Agree? So like this, as soon as you get, you will stop here, because now nothing new you will get. So what is the order of, tell me, what is order of A? That is this R. That is this R. That will be this number R. Remember, you already have inverse. Don't worry about negative. You don't have to go in the negative side, because tell me, what is your A inverse? This element will be your A inverse, right? This will be your A inverse, correct? Yes or no? And this is your identity element. So finally I can say order of but this should be the smallest. This should be the smallest positive integer. This should be the smallest positive integer. So then I can say order of A is equal to R. Okay, so that's it. I hope this everything is clear now. So this is the alternative definition of order of an element. What is order of an element? That is the least positive integer such that you will get identity element. This is another definition of order of an element. So we have two definitions now. Okay, so remember order of element definitions. Now we have two definitions. Order of an element. Order of an element definitions. So if you have a group, G comma star, and let's assume A belongs to G. If A is equal to E, then what will happen? Just tell me. If A equal to E, if A is identity element, then what is order of A? Means what is order of E? That will be 1. There is nothing to check here. Identity element order will be 1. Now, if A is not equal to E, then what will happen? Then I can say order of A is same as, what can I say? Order of A is same as, how many? Okay, subgroup generated by A. Size of subgroup generated by A, right? This is definition number 1. And what is another definition? What is another definition? Another definition is order of A is smallest positive n. Smallest positive n such that A power n is equal to E. Okay. These two definitions are same. So you can apply this definition or you can apply this definition. Both are same. So all these three things are same. So this means order of A. This is same as how, okay, what is the size of subgroup generated by A? Size of subgroup generated by A. And this is same as smallest positive n such that A power n is equal to identity element. Okay, because it's like this. Because where will you stop? So if I can say if order of A equal to n, or for example, if order of A equal to 5, then what it means? If order of A equal to 5, then what will happen? Tell me. Then this will happen. A power 1, it will be something A. A power 2 will be something different. It will be some different element. Basically, this means A can generate 5 elements. It means A can generate 5 elements. A can generate 5 elements. A can generate total 5 elements. So this will be D. And A power 5 will be equal to identity element. Okay, this is your identity element. Now tell me, what is A inverse? Where is A inverse? Where is A inverse? This will be your A inverse. This A power 4, this is going to be your A inverse. Very simple, right? So A order of A is 5. It means this is the smallest. Remember, this is the smallest number such that you will get A power 5 equal to E. This is the smallest. Don't forget about smallest. This is the smallest number such that you will get A power 5 equal to E. Okay. What about power 0? See, power 0 already you got E, right? For example, if I ask you, take this example. If you take this 1 comma minus 1 iota comma minus iota, and this is multiplication. If I ask you what is order of, for example, if I ask you what is order of iota, then what that will be? See, you don't have to start with iota power 0. You don't have to start with iota power 0 because why? What is the reason? Because anyway you are going to get iota power 4 equal to identity element. Is this clear? Are you getting my point? See, if I put like this, then this is a set. So this is a repetition, right? This is a repetition. Okay, so what you can do, you can simply you can simply go iota power 1, iota power 2, iota power 3, and iota power 4 will be the identity element. Okay, and you can notice iota power 1, that is iota. This is -1. And what is iota power 3? This is the iota inverse. This is the iota inverse. What is iota power 3? That is minus iota. So I can say iota inverse is what? Iota inverse is minus iota. Iota inverse is iota power 3. Is this clear? Tell me. Is this clear to everyone? So if you get identity element, then you don't have to worry. That's it. If you get identity element, now you don't have to worry about iota power 0 because you already got identity element. So you don't have to worry about iota power 0. You don't have to worry about negative powers because this is your iota inverse. So you don't have to go in the negative side because already this is your iota inverse. So that is the point. Okay, so I can say what is the order of iota? That is 4 because this is the smallest. If you notice, okay, order of iota, that is the smallest n, smallest positive n, such that iota power n is equal to identity element. So tell me what is the smallest positive n? Tell me what is smallest positive n such that this will happen? That is n equal to 4. So I can say order of iota will be 4. And this means iota can generate 4 elements. It means this is the size of subgroup generated by iota. This iota can generate 4 elements. Okay. So I hope this concept is clear. This is just alternative definition. Like, okay, if you don't want to confuse yourself, then this is just alternative definition of order of an element. So alternative definition, I can say this is your definition 2.